I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This video is on writing functions. The independent variable is the input of a function, and the dependent variable is the output of a function. There are some words that are interchangeable that you need to be aware of, or words that basically mean the same thing. When I talk about the x, I'm talking about the input, I'm talking about the domain, and I'm talking about the independent variable. When I say y, I'm talking about the output, the range, and the dependent. Make sure you know which words go with what variable. The dependent variable depends on the independent variable. The dependent variable is a function of the independent variable. The reason I want to point that out to you is because you may see a problem and it may say that the temperature is a function of the time of day, for instance. So in that case, temperature is the dependent because it's a function of something else, which would be the independent. So the temperature is a function of the time of day, temperature is dependent, time of day is independent. The output of a function will change as a result of the input changing. So if you think about a graph, if this is time and this is temperature, right? As the time changes, so in the morning the temperature is not as hot, but as the time, gets to noon, the temperature is going to rise, and then at some point the temperature may level off, and then it'll start to drop. Again, the time is what's affecting the temperature change. So the output depends and changes as a result of the input changing. So here's an example of a word problem, and we're going to write a function. So it says Emma babysits and charges $9 an hour plus a $4 travel fee. Write a function for the amount Emma charges for each hours. So I'm not trying to find specifically how much she makes for a specific number of hours. I just want a function rule that I could use to find out how much she would make for any number of hours. So function notation is that we are going to use what is called f of x. F of x is our output. So I'm going to go add that to our table up here. For y, we can also use f of x. So that's how you read this, f of x, meaning a function. F represents function of x. We also may have a function called g of x or h of x. Those are the three letters that are most often used. Again, that represents the output. This x is the input. That's the domain. So I'm saying I have a function of this input x. So in this problem, our x is our independent variable, which is our hours, which actually they want me to use h. So we're going to use h. Our dependent variable, which will be f of h, meaning a function of the hours, is going to be the money she makes. So the money Emma makes depends on how many hours she works. So this is our dependent and this is our independent. So what is the rule? Well, the amount of money she makes, which is represented by f of h, is going to be equal to 9 times the number of hours she works plus $4 for her traveling. So now that I have a function rule, if I know that she worked 4 hours, I can substitute a 4 in for h, and I could do 9 times 4 plus 4 is 36 plus 4 is 40. So she would make $40 if she worked 4 hours. Now this function is going to be a continuous function. Remember we looked at the graphs and we looked at continuous graphs and discrete graphs. The reason this is a continuous function is because the domain is actually going to be anything greater than 0. Right? If she shows up and works 0 hours, then that doesn't really make sense. So we want the hours to be greater than 0. She may only go work half an hour. It's probably not likely that she's only going to babysit for half an hour, but she could. So the domain is anything greater than 0. So it is a continuous function again because the hours can be anything greater than 0, as opposed to just being a specific list. It is possible to work half an hour or a quarter of an hour or things like that. If the domain is h is greater than 0, then the range, well, if she works 0 hours, she makes $4. So if h is greater than 0, then f of h needs to be greater than 4. Again, because if she works 0 hours, she would make $4. But we're saying she's got to work more than 0 hours, which means she's got to make more than $4. So that would be our domain and our range. And hypothetically, she could work an infinite number of hours, so we would just continue that on. Our next example says the admission fee to a local carnival is $8. Each ride costs $1.50. Write a function to represent this situation. So let's identify our independent and our dependent variable. And I'm going to use x and f of x. So x is our independent. Our independent variable, well, let's think about what our two variables are. The admission fee is $8. The ride costs $1.50. Okay, so what do we not know? Well, we don't know the total cost, and we don't know how many rides they rode. The admission fee is not a variable. We know the admission fee is $8. That is our constant. So our independent is going to be the number of rides. Our dependent, our f of x, is going to be our total cost. The total cost is going to depend on how many rides I ride. So now I can write a function rule. The total cost is equal to $1.50 times the number of rides that I ride plus an $8 entry fee that I have to pay. So even if I show up to the carnival and I don't ride any rides, I still have to pay $8, which that sounds reasonable. I know people that go to the rodeo, go to the carnival, and they don't do anything. They just show up. So they would still have to pay the entry fee. So that is our function rule. So again, now, if I knew how many tickets or rides I wanted to ride, I could find out my total cost. This is going to be a discrete function. The reason is because I cannot ride half a ride. So my domain is actually going to be 0, 1, 2, 3, 4, and so on. So that's how I would write my domain. I'm not going to use an inequality because, again, it's discrete, which means that there are specific numbers that are in the domain, and it's not like from some numbers to another number with every number in between, because I can't ride half a ride. So then my range, okay, so think about your domain. If you plug in a 0, you spend $8. If you plug in a 1, you spend $9.50, then 11, then $12.50, and so on. So that is your range. You're never going to, at this specific carnival, assuming that you don't buy any food or anything else, you're never going to spend a different amount than what's listed in the range, in the pattern that follows. Now we're going to look at evaluating functions. So it says evaluate the first example for h equals 9. So the first example was f of h equals 9h plus 4. So evaluate for h equals 9. So that means that we are going to plug in a 9 for h. Notice that I put a 9 here and a 9 here. We read this as f of 9, which means what is the value of the function when the independent, which in this case is h, equals 9. Okay, this does not mean that you multiply f times 9. That is not what that means. You need to write that down. This means what is the value of the function when h equals 9? You need to write that down. What is the value of the function when h equals 9? So the value of the function is 9 times 9 plus 4, which is 81 plus 4, which is 85. Now, what does that mean? H was hours. So if she works 9 hours, then she makes $85. Again, that's the value of the function. So the value of the function at 9 is $85. Evaluate the second example for f of x equals 17. So here is our function, and we're trying to evaluate for f of x equals 17, which means that is the value of my function. I don't know when that is the value of my function. So I'm solving for x. So I'm going to subtract 8 on both sides. 9 equals 150x. Divide by 150. X equals 6. So what does that mean? That means if I ride 6 rides, I will spend $17.
I've been waiting way too long.